Operating Systems, Features, Processes, UI and Management, Part 1. In this chapter you will learn about the various components of an operating system such as file systems and features, file management, services, processes, drivers, utilities, and interfaces. File systems and features. A file system is a method of organizing and retrieving files from a storage medium, e.g., hard drive. File systems usually consist of files separated into groups called directories. Directories can contain files or additional directories. File systems also differ in their support for data compression and encryption, how permissions are specified, whether journaling is supported, limitations on drive size, and naming rules. Today, the most commonly used file system with Windows is NTFS. File systems. With any file system, one of the important factors is cluster size, also known as allocation unit size. The cluster size represents the smallest amount of disk space that can be used to hold a file. For example, if a file occupies 2 KB of space in memory, it will actually use a cluster when stored. If the cluster is 4 KB, the file uses 4 KB when saved to disk. If the cluster size is 16 KB, the file uses 16 KB when saved to disk. When files are stored, their location is recorded in the file allocation table or master file table, which acts as a type of index to the contents of the disk. The number of entries allowed in this structure along with the cluster size are used to determine the maximum size of a drive and the total number of files it can store. A directory folder is considered the same as a file in making this calculation. When a disk drive is set up by an operating system, it can contain one or more volumes. Each volume can be assigned a separate ID, in Windows, a drive letter. Here are some of the various types of file systems you would need to understand for the IT Fundamentals Certification Exam. NTFS. New Technology File System, NTFS, is a file organizational system that stores and accesses information located on Microsoft Windows NT, Windows 2000, Windows XP, Windows 7, and Windows 10. The following are some major features of NTFS. Support for large hard disk drives, up to 16 TB using the default 4 KB cluster size. Support for journaling, which stores a record of changes to the drive. File compression and encryption, support for encryption not present in home versions of Windows. Permissions are used to control which users have access to a file or folder and what level of access is available. Timestamps when files and folders are created or changed use Universal Time Coordinates, UTC, also known as Greenwich Mean Time, and are displayed in local time per the time zone setting in the operating system. Current and recent versions of macOS and Linux can read drives that use NTFS. Third-party utilities are available to enable these operating systems to write to NTFS drives. Reading a drive includes tasks such as opening a file and viewing the contents of a drive or directory folder. Writing to a drive includes tasks such as erasing a drive, formatting a drive, which replaces its file system, saving a file, saving changes to an existing file, and deleting, erasing, a file. FAT32. File Allocation Table 32-bit, FAT32, is a file system used for storage devices, and file systems are ways of organizing storage on devices such as hard drives, SSDs, memory sticks, microSD cards, etc. FAT32 was the primary file system used for older version of Windows, Windows ME and 9X. It supports drive sizes up to 2 TB using its default 32 KB cluster size. However, FAT32's cluster size changes according to the size of the formatted drive. For example, a 4 GB drive uses a 4 KB cluster size. FAT32 also offers long file name support, enabling users to create file names longer than the 8 characters plus 3 characters file name rule used with the older FAT32 and FAT16 file systems. FAT32 does not include support for journaling, file compression, encryption, use third-party tools for these features, or permissions. For these reasons, FAT32 is used with USB flash drives or memory cards up to 32 GB rather than for system drives. For flash drives and memory cards of 64 GB or larger, use the XFAT, Extended File Allocation Table, file system. macOS supports read-write access to FAT32 drives, so you can use a FAT32 drive to exchange data between macOS and Windows computers. In Windows, you can use a drive's properties sheet to see the file system it uses. HFS and HFS Plus. A hierarchical file system, HFS, is how drives, folders, and files are displayed on an operating system. In a hierarchical file system, the drives, folders, and files are displayed in groups, which allows the user to see only the files they are interested in seeing. The HFS file system was developed in 1985 for use with early Macintosh computers. It has a 2 TB drive limit, a file size limit of 2 GB, and supports long file names. Up to 31 characters are supported by macOS Finder on an HFS drive. An HFS drive can only hold up to 65,535 files folders because it uses 16-bit block addressing. Because of its capacity limitations, HFS was replaced by HFS Plus, in 1998. HFS is still supported for read-only access on recent and current macOS operating systems. HFS Plus is also known as OS X Extended. HFS Plus supports drives up to 8 EB, exabytes, and an HFS Plus drive can store as many as 4.2 billion files because it uses 32-bit block addressing. macOS has gradually added features to HFS Plus that are similar to those found in NTFS. Journaling, optional in macOS 10.2, standard in macOS 10.3 and above. Permissions, standard in macOS 10.4 and above. Compression, standard in macOS 10.6 and above. Encryption, standard in macOS 10.7 and above. Third-party software is available for Linux and Windows to enable read-write access to HFS Plus files. ext4. The ext4, fourth extended file system, is the current version of a journaling file system for Linux. ext4 was introduced in 2008 with Linux kernel 2nd June 1928 and is also used by Android starting with version 2.3. The largest recommended volume size is 16 trillion bytes when using 4 kilobyte blocks, allocation units. 16 trillion bytes is also the maximum file size. There is no limit on the number of folders, subdirectories, on an ext4 volume. To determine the file system, S, for drives connected to a Linux system, open a console, terminal, session and use the command cat etc. aimtab. Entries beginning with dev are mounted drives. Features. Compression. Compression is a type of data compression that works by storing compressed versions of files on the hard disk. A disk compression utility sits between the operating system and the disk drive. Whenever the operating system attempts to save a file to a disk, the utility intercepts it and compresses it. Likewise, when the operating system attempts to open a file, the disk compression utility intercepts the file, decompresses it, and then passes it to the operating system. Because all applications access files through the operating system, disk compression utilities work with all applications. The entire process is transparent to the user, though opening and closing files may take a little longer. On the other hand, a disk compression utility can double the amount of disk space available. Compression in NTFS. In NTFS, you can compress a file with File Explorer Windows Explorer. Right-click the file. Select Properties. From the General tab, click Advanced. Click the empty Compress Contents to save disk space box. Click OK. Click Apply, then OK. A compressed file has two arrows pointing in opposite directions on the file icon or the file is listed in blue, depending on the version of Windows in use. This type of compression is not compatible with other operating systems. Compression in HFS Plus. HFS Plus, macOS 10.6 and newer, uses the Ditto command line utility with the HFS compression switch to compress a file. Ditto HFS compression original file name compressed file name. Almost all the system files used in macOS 10.6 and above are compressed. You can use Ditto to compress data files. To see information about a file compressed with Ditto, download an USAFS tool, a third-party utility widely available online. Creating archive files. If you want to compress files for emailing or for easier transporting on a thumb drive, you need to create an archive file. Here is how to create a zip, pkzip, file format with Windows, any file system, from File Explorer Windows Explorer. Select the file or files to archive. Right-click the file, S. Click Send to, compressed, zipped, folder. Press Enter to use the suggested name or enter a new name. The original files are not changed. To create an archive, zip, file with macOS from Finder. Select the file, S, to archive. Open the File menu. Click Compress. The file is saved as archive.zip. Each subsequent archive file is numbered, archive2.zip, etc. Rename the archive file, S, as desired. Linux uses the zip tool create zip files. Encryption. File encryption means providing security for files that reside on media in a stored state to prevent unauthorized users from viewing the contents of a file. Encryption is supported in the NTFS, HFS Plus, and ext4 file systems. To encrypt files in FAT32, use a third-party utility. NTFS encryption with EFS. NTFS uses the encrypting file system, EFS, to encrypt files on business versions of Windows. To encrypt a file with NTFS, use the Properties Sheet's Advanced dialog. NTFS indicates encrypted files with the padlock icon, Windows 10, or by highlighting the file in green, Windows 10 and earlier versions. The option to highlight encrypted or compressed NTFS file names in color is controlled through the Change Folder and Search options setting in the View menu for File Manager. If an encrypted file is copied to another drive by the original user, it is decrypted. However, if an encrypted file is on a drive that is taken from the original user's PC and connected to another system, it cannot be opened. EFS is supported only on Windows operating systems. Encrypted files can only be opened by the original user or by the holder of a recovery key, a special file that is created when you first encrypt a key. If you encrypt files in Windows, be sure to make a copy of the recovery key to a USB flash drive and keep that drive in a safe place. BitLocker encryption. BitLocker is a full-volume encryption feature included with Microsoft Windows versions starting with Windows Vista. It is designed to protect data by providing encryption for entire volumes. By default, it uses the AES, Advanced Encryption Standard, encryption algorithm in cipher block chaining, CBC, or XTS mode with a 1 to 8-bit or 256 key. CBC is not used over the whole disk, it is applied to each individual sector. BitLocker was originally designed to support only the system drive. See, BitLocker currently supports non-system drives. BitLocker to go also supports removable drives that use NTFS as well as FAT-based file systems. BitLocker works with either systems that have a Trusted Platform Module, TPM, version 1.2 or greater, or a USB flash drive. BitLocker credentials are used to unlock, unencrypt, a BitLocker drive when necessary. The user's Microsoft account online is used to store this credential information for safekeeping. A BitLocker to Go Reader app is available from Microsoft for Windows XP and Windows Vista. This enables a user of a BitLocker encrypted flash drive or hard drive to open the drive and use its contents on an older computer. HFS Plus encryption with FileVault 2. Starting with macOS 10.7 Lion, HFS Plus includes built-in encryption called FileVault 2. FileVault 2 differs from the original FileVault in OS X 10.3 Panther by encrypting both the user's directory and the startup volume. Users can also create and then encrypt a disk image using disk utility. The recovery key, which enables the encrypted drive to be read when the computer is not working properly, can be stored online. ext4 encryption. Encryption with an ext4 file system in Linux requires the user to verify the volume is compatible with encryption, enable encryption, create a folder that can be encrypted, generate an encryption key and store it, assign the encryption policy to the folder, and copy files to the folder. Permissions. Permissions refers to determining which users can perform operations on a volume prepared with a given file system. Of the file systems covered on the IT Fundamentals exam, FAT32 is the only one that does not support permissions. NTFS permissions. Permissions are assigned on a per user or a per group basis to a volume, a folder, directory, or a file. To see or change an object's permissions, right-click the object, select Properties, and click the Security tab. The top of the security window lists groups and user who have permission to access the object. Select a group or user to list its permissions. Standard permissions are set as allow or deny. They include the following. Full control. User can perform any action on the object, including deletion. Modify. User can change the object. Read and execute. User can open the file and run it. List folder contents. User can view the folder's contents. Read. User can read the file. Write. User can save a file to the object. Special permissions. Edit to change how permissions are inherited. To view the user or group's effective permissions, and to audit permissions. If a user or group cannot access a volume, folder, or file, the permissions need to be edited to permit the level of access desired. HFS plus permissions. HFS plus permissions can be viewed and set in three ways. Unix symbolic notation. Unix numeric notation. Finder sharing and permissions. To use Finder to view permissions, also called privileges in macOS. Select the File app. Click File, Get Info. Click Sharing and Permissions to view current permissions. To add a user and select permissions, click the plus sign. ext4 permissions. When you use the lsl command to view file information, Unix symbolic notation is used to display permissions. The notation RWRWR translates as thus. First dash indicates object type, is a regular file, C is a character special file, D is a directory. First group of 3 after the initial character. RW, R means user class can read file, W means user class can write, change or delete, file, and means user class can't execute, run, file, it's an image file. Second group of 3. RW, R means group class can read file, W means group class can write, change or delete, file, means group class can't execute, run, file, it's an image file. Third, last, group of 3. R means other users can read file, means other users cannot write, change or delete, file, means other users cannot execute, run, file. When you use the statc%a command to view file information, permissions are shown in Unix numeric notation. The value 664, some Linux distributions would display this as 0664, translates as follows. 6. Read and write for the file's owner. 6. Read and write for the file owner's group. 4. Read for other users. To change permissions for a file, use the chmod command. This command uses Unix numeric notation. To change a file from read-write to read-only, use the following command, chmod 444 filename.txt. Journaling. A journaling file system is a file system that keeps track of changes not yet confirmed to the file system's main part by recording the intention of such changes in a data structure known as a journal, which is usually a circular log. In the event of a system crash or power failure, such file systems can be brought back online more quickly with a lower likelihood of becoming corrupted. FAT32 and HFS do not support journaling, but NTFS, HFS Plus, and ext4 all support journaling. Journaling is enabled by default in NTFS, HFS Plus, beginning with OS X 10.3, and ext4. Limitations. Different file systems have limitations on the size of a volume, the number of files in a volume, and the number of files in a folder, directory. Naming rules. Although all the file systems covered support file names longer than the 8.3 limitations of MS-DOS, there are still differences in the rules that govern how long a file name can be. FAT32 File Naming Rules. FAT32, because it is based on FAT16, which limited file names to 8 characters plus up to a 3-character extension. For example, wordfile.doc actually uses at least 2 directory entries for long file names. This is a wordfile.doc, the actual file name. thesis1.doc, a short file name derived from the actual file name. To see both file names and short file names, SFNs, with a recent or current version of Windows, open the command prompt, cmd.x, navigate to a folder, and use the following command. dirx. FAT32 and NTFS File Naming Rules. FAT32 and NTFS support path names of up to 255 characters, including the file name. FAT32 and NTFS treat uppercase and lowercase names as identical. Here are some additional points to keep in mind. Reserved characters, \vertical bar, asterisk, cannot be used in a file name. However, you can put double quotes around a long file name if you are using an app that is not designed to recognize long file names. Device names, CON, PRN, AUX, NUL, COMX, LPTX, X is equal to 1 through 9, can't be used as a file name. NTFS File Naming Rules. NTFS supports both long and short file names by design, so the OS does not need to generate short file names. HFS and HFS Plus File Naming Rules. HFS supports file names of up to 31 characters. 8-bit characters except for colon can be used. HFS and HFS Plus store uppercase and lowercase characters as entered, but treats them the same when opening and using files. For example, if a file is stored as lower.txt, it can be opened by referring to lower.txt, lower.txt, etc. HFS Plus supports file names of up to 255 characters and does not have any reserved characters that cannot be used in a file name. ext4 File Naming Rules. ext4 supports case-sensitive file names. For example, mark.txt, mark.txt, and mark.txt are separate files in ext4. File names can be up to 255 characters. Allowed characters include AZ, numbers, periods, and underscores.